Hello, everyone, and welcome to Bird Process Equipment's um, welcome to Bird Process Equipment's webinar on pump lift station designs. I am Mark Girgenti, the Director of Design Engineering for Bird Process Equipment, and I will be I want to welcome you all today to this webinar. Today we're going to be talking about pump lift station designs, and pump lift station designs. By and large, really what we're talking about today, because I know there's a lot of different types of like pumping stations out there, and one of the things, obviously, really what we're focusing on today is going to be talking more about process-based. We're not going to be talking about things like sanitary lift stations or things like that. We're talking largely about, process waste lift stations, process lift stations, which are actually not handling waste, things that are actually going to be transferring into a process. And, when we're really delving into things like this, we're looking at items which tend to fall in the realm of being like thermoplastic in design or stainless steel. And these are utilized in a variety of different applications and industries. And, obviously with all of our webinars, for those of you joining us for the first time, for those of you who have listened to our webinar series in the past, we like to keep these webinars very casual. So if you have any questions as we go along here, feel free to type them into the chat window. We will try to answer all of the questions during the broadcast, and any we do not get to, we will send emails out afterwards. There will also be a couple of poll questions we're going to post during the webinar for those who are interested in answering those, and we will follow up with a brief survey as well for those who are interested in giving us their feedback on our webinar. So I hope everybody enjoys the presentation. So what exactly is a lift station? So what I like to say is lift stations are typically utilized when gravity is not your friend. And, a lift station is a device used to move solution from a lower to a higher elevation or from a location where gravity flow is not possible or would be impractical. And by and large, where you see this is, where you have a drainage application, whether you're coming out of a process, a suite, whether you're coming out of whether you have a biofarm reactor, you're in the semiconductor with various tools, you have some low point drainage that's going to come out of these systems. And this needs to be tied into a device that can then get it up to the actual gravity, if it's going to go straight to drain, or to some kind of a treatment-based system, such as a pH neutralization system, which would allow then for further treatment. So, they're fairly simple devices, but they come in a lot of different configurations, designs, materials, and they're used in a wide variety of applications. And really what we're going to do today is we're going to kind of highlight a little bit about the fundamentals of lift stations, talk about a few of the more standard designs that are out there, and then from there we're going to move largely into kind of looking at a lot of different examples just to kind of highlight, kind of how these systems go together for a variety of applications. So let's talk a little bit about lift station basics. You can see here, kind of a very basic lift station, kind of a PNID here on the screen. And when talking about a lift station sizing, there's really two things you want to size. One is going to be the pump flow rate, and then the other is going to be the other one's going to be the tank volume. So for a lift station, despite the, you really want to size this for the maximum amount of instantaneous flow plus 10% to ensure pump down. So if you're looking at sizing these, you really do not apply much in the way of a diversity factor to a lift station for sizing. You want to utilize it in such a way that you can always pump down, because obviously the risk of not being able to handle sufficient flow, is obviously backing up your pumping system. And you always want to be a little bit higher than that, since a lift station is designed to cycle and allow you to pump down the unit. As far as standard lift station volumes are concerned, generally all you're really trying to shoot for is that you size the lift station so you don't short cycle your pumps. Now, depending on what kind of pump that is, whether it's a centrifugal pump, a some style pump, those requirements will vary. But by and large, 3 to 5 minutes of residence time is kind of a good kind of rule of thumb when coming up with a lift station design for standard sizing. So as an example, if you were going to have a 30 GPM lift station, you'd want somewhere between a 90 and 150 gallon tank approximately. It's kind of a good rule of thumb. Now, obviously, practical considerations have to come into play with this, and very often this is kind of getting a little bit away from the standard design. If you're looking at things more like equalization tanks or devices like that, you would obviously want to upsize that, then have some additional residency time. But if you're simply just trying to pump the waste, as basically a standard design, 3 to 5 minutes is kind of a good rule of thumb for sizing one of these systems. Lift stations generally come in two primary configurations: simplex and duplex. There are rare cases where you will see more than duplex pump configurations, but really by and large, simplex and duplex lift stations tend to be the most common. Simplex probably not so much. So it's in a simplex lift station, it's kind of as it implies, you have a single pump as part of your lift tank design. And these tend to be smaller units. Really, the real reason to use a simplex lift station is really cost and footprint driven. Once you need to add in a second pump into these systems, the system needs to get much larger. And some of these are really designed to go under even like a single like lab sink, for example, as you can see here in the picture on the left, where this will literally just slide under a sink, and then it will allow you to basically be pumped out from there. So they're very good from a room standpoint. They can be very economical, but they do have some downside. You only have a single pump, so you don't have any kind of redundancy. So these are really best utilized in applications where, you know, either A, you're kind of forced to because of a room allotment, or two, because you would utilize them as a means to allow really when you not really, it's not a critical process, or it doesn't really matter if the system has to come down for some amount of time, in the application. And these can range again from very simple ones like you see here on the left to obviously much more complicated designs, more for say like a semiconductor tool that you would see here on the right, where this is more of like a PVDF based material. As a standard design, you can see these can be very small. This particular unit here is a foot by a foot by a foot for the tank, and then you just have a basic pump design, and you have a simple on-off slope-based level control for these units. As I mentioned before, standard simplex lift stations are often utilized under a sink or a single process source. They're not a good choice when you're dealing with critical process applications. Initially, not a good choice. Where you're going to have to, include device. We're going to have to, pump down an entire floor, entire process suite. These can also, though, have a lot. These can have some different options added into them, kind of for that protection or lack of redundancy in them. They often have alarm features added for high-level alarm, and they can also have leak detection as well, just in the off chance that you do have a pump fault failure, and no one realizes that based on the basic, controls that come in the standard. So there are a number of different options available for these types of systems. Duplex lift stations, I would say, are probably more common, and obviously because introducing any kind of a pump into your drainage line, as a requirement, introduces a point of failure. Having a duplex lift station gives you that assurance that you have backup and redundancy in the systems. And you can see here a couple of different examples. As a standard, duplex lift stations, are set up for, basically for alternating pump control, whereby when each time a pump kicks on, you'll alternate between the two pumps to allow for even wear across both units. You generally also set them up in a lead lag configuration. And what that means is you have a 4-point control in a lift station where you have a pump off point as your lowest point, and then as the water level begins to rise in your tank, you have a pump, you have a lead pump on, and then as the water level continues to rise, which obviously it shouldn't, unless you have additional drainage coming in or you have a pump failure in the lead pump, your lag pump will turn on, and then finally you'll have your high level alarm. So they're generally not. They generally are set up in a situation where you can have both pumps in operation to allow for use. And fundamentally, a duplex lift station is not set up all that differently, at least as a standard unit from more of a simplex style system. And but again, because of size, sometimes simplex lift stations are more practical, particularly for smaller applications. You can see here, a basic duplex lift station, you are going to be getting up there just to have room for the pumps. Now we're going to take a look at a little later in this presentation, some of the more um, custom units, and those have some different options for allowing pumps to be mounted in a different configuration. But by and large, duplex lift stations do tend to be a more common choice, especially when you have critical process redundancy, and really when you just cannot afford to have shut down. Whether you're treating the entire floor, or you're trying feeding entire facilities worth of waste coming to the system, then you really do need that duplex capacity, or and that redundancy based in your system. Per process equipment has a number of standard lift station designs which are available, and you can kind of see here is kind of a part builder that we utilize, and we can work with various clients and engineers on. And these range from fairly small lift stations around a 7 gallon. That's the image of the drawing I showed earlier in the presentation, up to just a standard size of 260 gallons, with flow rates ranging from a couple of GPM out to about 80 gallons a minute for these units. And these are handy, in a very wide variety of applications, as they're a standard configuration, and they do scale for a lot of different laboratory applications, indoor process or industrial applications. But these are obviously just the beginning. And what we're going to kind of move to going forward here is kind of talking a little bit more about how custom lift stations are designed and sort of what their applications are. And I just kind of want a couple of notes on this. You can really run these at a lot of different voltages as well. That's a question I do often get with lift stations in general, but also with standard lift station designs. Almost any lift station can run, either single phase, um, 115, 230 volt, or three phase 230, and then 480 volts. Some of them just kind of make more sense to run it in a different configuration, and some of the smaller lift stations can actually be plugged into a wall outlet. Generally, when you get into anything above a half or three-quarter horsepower, you probably want to have some kind of a disconnect or motor starter. Smaller ones you can kind of run off of, more like a relay or just an outlet-based design. But it certainly can be looked at to see, and it can match a lot of different voltages depending upon what's available. It's not uncommon for a lot of lift stations to be utilized in like retrofit applications where you're converting over one space to another, and hence the reason why you can't go by gravity to your system. You would be adding, a lift station to get your new processee to your drain. So it's very often that these have to kind of either one match the footprint requirements, but two, also match whatever voltage is available in the given space. And this is kind of a blown up image here. You can kind of see the part number breakdown. A majority of these lift stations are thermoplastic or stainless steel. The standard ones are polypropylene or polyethylene. There are other options available as well beyond just stainless steel. In these two base units, Hastelloy is an option for certain unique applications, coated stainless steel, and also PVDF as well, depending on the nature of the chemicals that could be coming into the process equipment. So before I make the jump into custom lift stations here, I do want to have our first poll question. Again, for those who are interested in it, just going to take here about 30 seconds to just take a brief answer on what we've talked about so far. All right. So the poll question was, when should you utilize a duplex lift station? And as most of you guys obviously answered, it's all the scenarios that are listed below. When redundancy is important, when you have a critical process application, when downtime or backing up a system is important to you. Really, any one of those situations, would require a duplex lift station design to be utilized. And as you can see here, we're talking more about custom lift stations. All the ones on this slide are all duplex. And when you kind of talk about custom lift stations, these can run from very complicated lift stations where they're going to be utilized for particularly corrosive chemical, where they're going to be utilized for explosion-proof applications. They can be very large in size. If you have, for example, lift station requirements for a very large process application, where these things can scale, not just 260 gallons, but things, lift stations that are 7 or 8,000 gallons in those cases at very high flow rates, or they could be a very custom geometry. And sometimes they're not waste at all. Sometimes lift stations are also utilized, for process applications and transfer as well. So again, talking about custom lift stations, there really is a wide variety of applications where this can be utilized. And by and large, flow rates for custom lift stations can be, fractional to 1 gallon per minute up to, systems as large as 1,000 GPM. Pump technology varies. Most of the standard units, they'll utilize a vertical centrifugal pump. These could be vertical or horizontal centrifugal. They could be a positive displacement, a gear pump, a magnetic drive pump, a magnetic drive self-priming pump. Air-operated diaphragm pumps are fairly common. Deep sets, vertical pumps. It really depends on the application that you're trying to utilize. And then obviously tank geometry as well, ranging, from very small, up to very large, and depending on what the different geometry is. Being custom doesn't necessarily mean being, being larger. There's a number of applications out there where you're going to have like an autoclave, or you're going to have a semiconductor tool or sterilizer, and they're going to have an invert coming off of those units, a few inches off the floor that they need to pump. And, where a pit's not possible, you'll make lift stations that are very custom with side mounted pumps and, designed for very high flow. And then, so it's not just a size, it also just has to do with the overall configuration, that these can attune to based on what the drainage is, the temperature being drained, the flow rates, the chemicals involved. So there's a number of specialty options, double containment. They can have agitation in them if solids are present in the unit. They could be utilized more as an equalization tank as opposed to just a true lift station, where you'll have some level of residency volume in there to allow for transfer to a downstream process, or for example, like a pH neutralization system. A lot of different specialty controls, which we'll talk about a little more later. Materials can vary considerably as well. As I mentioned, polypropylene, PVDF, stainless steel, Hastelloy fiberglass, as well as a number of different configurations. So, it's kind of hard to encompass everything that could go into a custom lift station. So what we're going to kind of look at here is just, kind of a few different examples, sort of highlighting, how some of these different how custom lift stations kind of come into being, and sort of what some of the components are that go into these types of systems. So our first one here is from the semiconductor industry. And in the semiconductor industry, a lot of times what they're doing, coming off of a lot of these tools, can be extremely hazardous chemicals. In this case, it's a hydrofluoric acid waste-based system. And HF, for those of you who aren't familiar with it, is a very strong contact hazard. It can actually be fatal if it comes in contact with your skin. It also does have a fair amount of corrosion. It also does have a fair amount of corrosive properties associated with it. So this type of an example, you're building a lift station that really focuses on safety and containment in these systems. So, because of the chemical nature of these, this would be PVDF, but also be double walled. To prevent any kind of leakage from the system, and you'd even have splash and spray protection. You can kind of see in the photo there around the lift station design to allow to prevent any kind of leak or pressurized leak from the system from getting out onto an operator. There's air operated diaphragm pumps utilized for complete pump drain down because they have very high self-priming capabilities. You have leak monitoring both in the pump as well as in the tank itself, and these generally have more. Generally, custom lift stations tend to have a little bit more sophisticated control suite as well, where because this is a critical process, they'll have that monitoring capability in the system. They'll be able to output that information to a BAS or building management system as well, to monitor for leaks in the system. But it's hard. It's still just a basic lift station. It's a duplex design. It still has the same points, for transfer. Um, it just kind of moves into a more custom range, again, in this case, based on what chemicals are being utilized in the system. Those agents can also be located in clean room environments. And this one, obviously, when you're talking about a clean room environment where you need to make transfer out of there, you need a washable material, in this case, stainless steel. Things have, you have pharmaceutical grade stainless steel cabinets, you have non venting motors because of the class rating of the clean room environment. And they can also, and also this is all stainless steel, design, for that cleanliness, and also the duplex pump arrangement as well. So again, lift stations can also be placed in cabinets. As you can see, this is one example here. And cabinets offer a nice option for a lot of lift stations. In this case here, in a clean room, you're trying to basically prevent anything from the actual lift station from getting into the class environment, but also it does offer you an integral level of both leak detection, as well as any kind of spray protection in the unit. And we start talking a little more about solvent-based lift stations. It also gives you the ability to prevent any kind of a fume readings or from any of the solvents from getting out, gases from getting out of the cabinets. So it allows you to have a better area classification from an electrical standpoint rather than going class 1 div 2 or class 1 div 1 in those cases, because you are containing the actual fumes that could be coming off of the lift stations from the waste that you're actually dumping. In this example here, this is kind of your common pharmaceutical lift station design. Um, Again, you're talking about larger production suites, pharmaceutical lift station, waste dump. They could be a lot higher volume, than more of a standard design would entail. And this is kind of the collection sort of equalization tank option where this would be coming into a system and then allow you to pump into a downstream process. See, as such, you have a much larger tank, 1,250 gallons. It's going to be located in a pit where you're going to have basically all of the drainage from the facility coming to it. It has in-tank pH monitoring for like feed forward control into a system, 250 GPM, more deep set and power pumps, stainless steel piping on these. Generally, that's just done because you're trying to match the piping involved. There could be a temperature concern. A lot of times, if you're dumping like sterilizers or if you're dumping like clean steam or kind of or blow down into more of an industrial lift station, you do have to look at making it more temperature resistant in those cases. Basic standard lift stations can operate, um, generally like 140 for polyethylene, 185 for polypropylene, and then if you're going to go into more 2 to 220, you're going to be fiberglass or stainless steel lift stations. So material consideration also comes into play based on the nature of the waste that you're putting into the system. Just showing a PNID here. as you can see, you have your tank coming in, you have your level transmitter, you have redundant high level switch is another option, which oftentimes comes into play as you get to more bigger lift station designs, where in case you have a primary level switch failure, you do have that redundant basis for high to alarm at a redundant high level. And then, again, it's a lift station. You have your duplex pumps, some monitoring pressure switches. Um, Again, at their heart, all lift stations do follow a very similar design. What changes them and makes them more custom is their sizing, their materials, their pump selections. As I mentioned, earlier, there are ways also so that lift station pumps are not always even integral to the tank that they're actually drawing off from. In this case, they have more of a pump skid design where you're going to be drawing off of the tank with more of like a magnetic drive style pump. And again, this really depends on the application. Sometimes, it's more practical to have just a side mounted pump design, depending upon room access, if the tank's strictly tall, if it's actually more of an equalization tank. Here in this case, they have a polypropylene double wall tank, and they have ultrasonic level, really, because this was actually a very tight footprint design from an overhead standpoint. You didn't want to have a lot of pumps sticking out of the top of the stations. They have more of a pump skid design. This can also be the reverse, whereby you can use a cell priming version of a pump like this and then draw out of a tank in the pits where you'd have a separate pump skid design as well. So, um, this is just one of the options which is available where you would have you'd separate the pumps from the actual tank and make it more of a skid-based transfer system. And then not all lift stations deal with waste. Very commonly, as we've kind of talked about, a lot of the lift stations that that are utilized, they'll be taking waste from a tool or a process or blow down. But sometimes you'll also use, obviously a modification of a lift station to actually feed a chemical into a system, almost like a large chemical transfer system. And that's actually what this is in this case. This is a CJMP for transferring glycol, into the production area. You have, U.S. class, you have U.S. class 6 materials, FDA approved plastic, all sanitary design for these, and then, like a peristaltic pump for both transfer as well as for filling this tank as well for transfer into the unit. It's also known as sanitary piping and pumps, are common in an application like this, but they're also very common when you're dealing with waste that could be from a biological source. So if you have waste that then needs to go just like an EDS or a biokill based system, where you're going to be doing like thermal kill, or you want to be able to steam sanitize your lift station or part of your drainage system. A lot of people will use more of a sanitary pumping design for those type of waste lift stations as well. So sanitary, well, maybe seems counterintuitive, is oftentimes utilized, in process waste lift stations as well, just because it gives you that ability to really do that steam cleaning where you may have a biological waste that you're ultimately pumping and transferring from your system. Looking at this from a PID standpoint, obviously this is a little bit different, than what we've been kind of talking about before. You have a storage-based tank, where you're doing transfer from, a reagent tank in and then a simplex pump for transfer out. You're going to be controlling pressure through the glycol transfer loop into the CGMP area. So a little bit of a different design, but I wanted to kind of highlight this to show that, this type of like transfer system design isn't always just for waste, but can also be utilized, for more of a process-based transfer as well. Before we get into a little bit more about solvent and hazardous stations, I think we're going to do our second poll question at this time. So if anybody would like to review, and feel free to answer, we'll kind of discuss this. All right. So the question is, when designing a lift station, what diversity factors are applied? Um, in this case, when talking about process base, we are saying we are applying no diversity factor. We are assuming it's going to be the full flow rate. Um, that could be that that would be handled by the actual system. There are different circumstances where you would look at some different diversities, but it does depend on the application. But by and large, for most transfer-based systems, they're gonna the pump size for whatever really plus 10% of what the actual flow coming into the unit would actually be. So as I mentioned, kind of a subset of custom lift stations is hazardous, is solvent or hazardous location lift stations, and we've touched on some of this already as we've kind of gone along here. But when you're moving out of the realm of aqueous-based waste and you're talking about things like volatile organics, or things like that, which obviously have a lot of off-gassing involved in them, and this is very common in pharmaceutical as well as very common in the semiconductor industry. Lift stations are generally are designed to handle these hazardous chemicals. And they come really in two primary styles. You have, your standard lift station, more of a duplex design, like you see here on the right. When dealing predominantly with hazardous or volatile chemicals, you're almost always going to be a stainless steel design just due to chemical compatibility. And you're going to use an air operated diaphragm pump. If you're trying to mitigate a lot of electronics, you might want to run the system all on 24-volt DC because you will be in a class 1 div 2 or class 1 div area for a lot of these units. The other design is to build them more in cabinets. And much like our earlier example, where we were looking at a clean room design, this type of configuration is more utilized um, to the cabinet to have a lot more of the safety features. So you still have that control where you're going to have, you can keep the fumes in, you can possibly allow for a lower classification area outside of the cabinet, but cabinets can also have fire suppression systems integral to them. They could have pipe away or concert or flame arresters on them. They can also have self-closing doors. Should you have an issue where you do have a fire-based system in there. So there's a lot of things that can go into really more safety with these units. Um, but they still follow obviously the basic lift station design, and they can be made very custom. As you can see here, this is a very small unit, which again is a further cabinet-based design, which can be utilized. And this is typically it's about the size of a microwave, where you're pulling off one semiconductor tool in that example, and you're transferring it out. And you have leak detection. You have a class 1, div 2. You can also have very specialty control panels as well with these types of systems. So this is obviously kind of a big thing to kind of consider. Should you go down that route, understand the area classification. Um, is very critical for designing lift stations. For that type of application. Behind just solvent, there's a number of other types of a little more custom options that come into play with these types of systems. The example here on the right, these are all PTFE coated lift stations, and this comes up a lot when you have very strong chemistries involved. And in this particular example here, these were tanks that were in a pit, and those are actually the suction pipes that are all coated as well that come up to more of a pump-based skid. And you can, in place of just say making, a Halar Teflon line tank, your Teflon tank, which isn't very practical above a very small size. Coating of the tanks is a very viable option, for very strong chemicals, that could be utilized in the plant. Um, so that's definitely an option which can be utilized. Again, it's very chemical dependent, whether you'd want to do that or not. Looking at the example here on the left, this is a fiberglass based tank. Fiberglass is fairly common material when it comes to lift stations. And one of the reasons it is because it can have a higher temperature resistance sometimes, but it can also be buried. One of the things that comes up sometimes is, if you have a lift station, can you put it in a vault, or can you direct bury it? In by and large, thermoplastic tanks really cannot be direct buried to the rim. Fiberglass, on the other hand, can be to some degree, so that kind of comes up as an option, not completely buried, but it is an option that can be backfilled. Um, so that's why fiberglass is utilized sometimes. It does have some downsides of the more thermoplastic based designs. As you know, with fiberglass tanks, it's very hard to make changes to them in the field. So if you do have to change fitting locations or change flanges, you have to like reglass in the unit, which you obviously, compared to a thermoplastic tank design, you'd be able to do that much easier. And then just showing in the center, the image here in the center, that's really what a self-priming design is, where you have more of a long or taller tank in a vault, and you have a self-priming pump design that basically sits on top of it. So that's very common as well, with these types of units. Just showing a very brief video here, kind of this is some of the different ways that some of these more custom lift stations are made. And just because they're custom does not necessarily imply that there's a lot of cost necessarily involved. I mean, it certainly can be the case. Um, but they are made, you're not, so there's a lot of options when you're making these, from building different tank designs, different tank geometries. You can really make them very specific to the application because you are making them largely, as needed in the custom arena, more from scratch here. So in this example here, they're just showing how the tanks are bent, to match a particular, geometry, in this case, more of a square or a rectangular tank design, for these units. And then kind of, looking at some of the images here, these are more of like a, pharmaceutical grade stainless steel tank. You can see here, duplex design, designed for high temperature waste coming out of a CIP based suite. In this case here, all welded construction, for leak protection, in these cases, pulsation dampeners. This is the kind of things you would very typically see, in more of a pharmaceutical or very heavily industrial plant. And then looking up here in the upper right, this is actually an all Hastelloy lift station. And again, designed for very particular chemicals which are involved. These have a number of different features. They have argon regulators in them. They can have nitrogen purging in them. And these are some of the different options that really can come into play, when doing, again, depending on what the nature of the waste or what you're actually trying to transfer, these can get extremely custom in those cases. And then, controls. I've talked a little bit about control panels, for lift stations. And for a lot of standard units, lift station controls can be, very straightforward. You can have a simple pump on, pump off control. Duplex, you can have more of a 4-point configuration. Looking at the example here, in the upper left-hand corner, that's a fairly standard duplex panel. You have pump HOA switches, you have a pump lead lag, alternator controller, and then you have a few disconnected motor starters for these. From there, these can really scale. Obviously, like an example here, the explosion proof lift station unit. This is all NEMA 7 at this point. Um, same basic operation, but again, when you're talking about hazardous-based design, it can be very important. Obviously, if you either need to use a NEMA 7 panel such as this, or you need to use a purge-based control system as well. That's why it's important, in doing solve is to understand, how exactly you want to set up the controls, for these systems. And then from there, they can really scale. And some of the examples we talked about today, there are PLC-based controls for these units. They're going to integrate them into more of a master-based system. Um, whether or not they wanted, they wanted the readouts. So really, the controls for these systems can go from very simple up to explosion proof, up to much more complicated as far as like PLC-based controls, for these applications. That concludes this webinar here. I just want to give everybody an update on future webinars before we get into some of the questions that we have. Coming up on June 23rd, we have a chemical feed systems webinar. And then we'll take a little bit of a break through the summer, and then we'll do high purity water system design on September 15th. And then we're going to have custom engineered systems on November 10th. So I believe the links for those are up, and those will be, I think, also in the survey as well. They'll be coming out to all of you. I just wanted to give you guys an update. So if you enjoyed this webinar and have interest in Chem Feed, hopefully I'll see you guys all in June. And now, to get to some of the questions we have, and again, if anybody has any more questions, feel free to type them, into the window here. We'll try to address as many as we can on the air, and if not, we will get back to people. So our first question is, can you bury a lift station? I think, this came in a little earlier. As I mentioned before, you really don't want to direct bury a thermoplastic lift station. And that really has to do, not that the lift station itself can't necessarily support the weight of the lift station. Generally, the problem is if you have a tank and it's even a lift station tank and it's full of fluid, you'll have an exterior force which pushes against the tank walls. So that, when you actually do backfill it, it won't push against it. But a lot of times what I've mostly seen with these has been more like installation errors where they'll basically just collapse on one side of it. So fiberglass, probably a little bit of a better alternative. Stainless steel can also work to some degree, but probably not a recommended thing for thermoplastics. What inverts can you use for the inlet on a lift station? That's kind of a complicated question. So I guess I'll kind of address that one in multiple parts. The invert, kind of affects a couple of different things. If you're talking about a standard lift station where you have a vertical centrifugal pump, you have to make sure that the invert of into the tank is above the pump and power. So you have an on point where your pump and power is submerged. That being said, where that's not practical, and you have an invert which is going to be lower, then that you would probably want to change the pump technology in that case to away from a more of a vertical centrifugal to either a bearing style pump or a self-priming pump. Or if your tank just kind of has to get too small at that point, for example, if you're coming out of a very low tool drain, you'd be looking at more like an air-operated diaphragm or something that can really, partially be drawing air at that point, because you just won't have a lot of residency volume in your tank to allow that to draw out. Now, one of the things I know about inverts that comes up a lot is when you have a pit and you have an invert pipe coming in. So your invert pipe coming into your pit may be 4 feet below the grade, maybe 5 feet below the grade. In that case, if you're putting a lift station in there, you really have 2 alternatives. One, you can put a lift station in which will be below that invert. So you have a tank or a reservoir, and you either come in through the side or come in through the top, and then have pumps mounted there, which would then force the pumps to be 4 or 5 feet, from the finished floor, which is an option. Or you can make the tank taller, and you have the fitting come in through the sidewall, and you locate the pumps on top of the tank, and then you basically have a dead space of air above your invert to where your cover is at that point. Or option 3, I guess, you put a reservoir down there, and then you have a self-priming pump skid that basically draws out of that. So There's a number of different ways to do that, and it is a fairly common thing. And unfortunately, based on the inverts coming out, it may force your lift station pit to get deep. If you have a very high flow rate, it's something to kind of consider how deep you be able to go, really below that, to allow for operation in those cases. So, you know, that's something, if you need to have 1,000 gallons of volume and your invert's 5 feet deep, you may have to go 5 feet deeper and then go 10 feet at that point. So there is a number of things really to consider there. So that's where you talk about inverts. It really is application specific. Is one, it can affect lift station, height. It can affect the pumps selection. It can also affect the, again, just how exactly the lift station is configured overall. Can the controls be hardwired? Can the controls be wired to the lift station? Yes, they can. You can actually mount a control box to a lift station. It may or may not be practical in some cases, depending upon how the lift stations are set up. So if you do have depending on how they're configured, the lift station stays under a counter, say it's a very small lift station, that may not be practical to have a control box down there. If it's sitting more on a grade level, then yeah, it's almost like you can basically just put some strut on there and basically mount a control panel. It comes more as a pre-wired package. So that's definitely an option, in those cases. Do process lift stations need vents? I would always recommend putting a vent on a process lift station. It doesn't necessarily have to be vented to something. It can be atmospherically vented. In those cases. But especially as you get more into more of the custom units, you definitely want to verify what kind of venting requirements you require based on what you're pumping in those cases. But yeah, you definitely want to have a vent on a lift station. One more here. What is the smallest lift station that you can make? Smallest lift station that's probably practical for me to make is about 5 gallons. And the reason I say that is there reaches a geometric limit where you can actually get the fittings, the instrumentation, into a unit. So there is kind of a limit to how small you can actually make a lift station. There is a limit how big you can make one. I mean, you can make lift stations that can basically draw out of large concrete vaults essentially, but sometimes the more custom units are actually the smaller units in those cases, and when you do have a very particular process fee, but generally speaking, about 5 gallons of reservoir size is probably about the smallest that you could realistically make a lift station at that point. All right, that's all the questions we have for right now. If anybody has anything else, certainly feel free. We'll kind of hang out here for a few more minutes with the chat open. And any questions, feel free to email us as well. I want to thank everyone for joining us today. And again, if you have any questions, feel free to reach out. Thank you very much.